In this training segment, we're going to take a look at an animated view of the refrigeration cycle. Our learning objective is to clarify our understanding of how heat transfer occurs in the refrigeration system.
This is an illustration of a typical air conditioner refrigeration system. The components that make up the system include a metering device, evaporator coil, suction line dryer, compressor, condenser coil, liquid line dryer, and liquid line. Now let's take a tour of the refrigerant system loop and check out the purpose of each component. The metering device is a good starting point as it is the start of the low pressure side of the refrigerant system loop. The metering device functions as a restrictor or regulator for the refrigerant. On the input side of the metering device, the refrigerant is at a high pressure, high temperature, a condition that transfers heat but in the wrong direction at this point in the system. It would be expelling heat instead of receiving it. Remember, hot goes to cold. We want the refrigerant to be cold and capable of accepting heat as it enters the next device in the refrigerant system loop. To achieve this condition, we use the refrigerant's properties of high pressure, high temperature, low pressure, low temperature. By forcing the refrigerant through the metering device, a drop in pressure occurs, resulting in a significant lowering of the temperature of the refrigerant. Now that the refrigerant is at the desired lower temperature, we now enter the evaporator coil, the next component on our tour of the refrigerant system loop. The evaporator coil is where the air that we are trying to cool is reduced in temperature. As the warm air passes over the evaporator coil, the heat energy in the air is transferred to the refrigerant in the evaporator coil, resulting in the lowering of the air temperature, the effect that we are trying to achieve: cooler air. Something must now be done with the heat absorbed by the refrigerant. To do this, the heat-laden refrigerant is now removed from the evaporator by way of a suction line. This line is a length of tubing that is easily identified in the system, as it is the tubing enclosed in insulation. The refrigerant travels through this tubing until it reaches the suction line dryer. The purpose of the dryer is to act as a filter and remove any moisture and contaminants that may be in the refrigerant. Once the refrigerant passes through the dryer, it enters the compressor. The compressor does exactly what the name implies: compresses. In this case, it is compressing the refrigerant. By compressing the refrigerant, the pressure of the refrigerant is increased, which also increases its temperature. Remember, high pressure, high temperature, low pressure, low temperature. Okay, so now we have refrigerant at a high temperature. Is that good? Yes, it is. From the output of the compressor, the high temperature refrigerant now enters what is called the condenser. This component is where the heat in the refrigerant, which is now at a higher temperature than the surrounding outside air, is able to be transferred. Remember, hot goes to cold. In this case, it is the heat in the refrigerant that is being released to the outside air, which is at a lower temperature. As the heat is being transferred, the refrigerant is condensing into a liquid, which brings us to the next part in the refrigerant system loop, the liquid line dryer, another type of filter. Even though this dryer performs the same function as the suction line dryer, the liquid line dryer is removing moisture and contaminants from refrigerant that is in liquid form, therefore requiring a different type of filter. After passing through the liquid line dryer, the liquid refrigerant flows through the liquid line. This line is the smaller of the two lengths of tubing that connect the indoor and outdoor units together. It can also be easily identified as it is the uninsulated tube. After passing through the liquid line, the refrigerant arrives back at the metering device, our starting point in the tour. The refrigerant has now come full circle and is ready to repeat the process over and over again. Two items not previously mentioned are the indoor blower fan and the condenser fan. The indoor blower fan moves the indoor air past the evaporator coil in order to transfer the heat in the room air to the refrigerant in the evaporator coil. The condenser fan moves the outside air past the condenser coil in order to transfer the heat from the refrigerant in the condenser coil to the outside air.
Let's review key topics just reinforced. We reinforced the understanding that evaporator coils operate at low pressure and are very cold. Remember, hot goes to cold. We also reinforced our understanding that cold liquid that enters the evaporator coil is boiled off to a cold vapor. The vapor travels in the suction line to the outdoor condensing unit and may encounter a dryer called a suction line dryer. The dryer keeps the system clean and free of moisture. The refrigerant vapor then enters the compressor where it is compressed to a high pressure, high temperature. We compress the vapor to raise the temperature of the refrigerant. The high pressure, high temperature refrigerant is pumped into the condenser coil and hot goes to cold. The heat from the refrigerant is transferred to the outdoor air and the hot gas will condense to a liquid. The liquid is then repumped to the indoor coil where at the metering device a pressure drop occurs and the refrigeration cycle repeats, and repeats.